All right, we talked about standard form for quadratics. Let's talk a little bit about vertex form and intercept form. So a couple alternative ways that we can write a quadratic equation makes it a little bit easier to graph. So let's go ahead and do that. All right, so first, here's vertex form. We've got y is equal to a, right? Similar to a that we used in the previous example, in the previous ones, right? Y equals ax squared plus bx plus c. In this case, we've got h and we've got k, okay? So h and k are going to be the vertex. Oftentimes people would say that's sort of like the same, it's sort of like an absolute value equation, right? So it's technically sort of like we're talking about the distance something is away from something else. In this case, from the axis of symmetry. So then we have the axis of symmetry, which is going to be equal to h, okay? In this case, really what you're doing is, the reason we set it up is because whatever h is here, if we have h minus h, the whole thing ends up at 0, okay? And then we're going to end up with 8y is equal to k. That's why h comma k will be the vertex, okay? And it just gives us a nice handy way of writing it, quickly being able to see the vertex where it is without having to calculate negative b over 2a or any of that fun stuff. All right, so what about a? All right, so same idea. When a is less than 0, right? When it's negative, okay? If the a here is going to be negative, the whole thing's going to point down, right? It's going to open down. And if a is greater than 0, meaning if a is positive, then we're going to want to know that it's going to point upwards, okay? So what I want to ask you now is, and you're going to answer a question here on your own, is what happens if a is equal to 0, right? What if a is equal to 0? What if a is equal to 0? All right, let's move on. So let's go ahead and take a, we've got a parabola right here, right? Y is equal to 4 times x minus 3 squared plus 1. So what we're going to do is let's go ahead and let's find the vertex, right? In this case, the vertex is going to be at x, right? When x is 3, right? So we said h comma k, right? This is going to be the vertex. So h, meaning this is going to be 3, right? So 3. So if x is 3, 3 minus 3 is 0, whole thing goes to nothing, and this is going to be comma 1. All right, so 3 comma 1 is going to be our, let's make that a little smaller. So over to 3, up 1, so here's my vertex. Okay, this thing is going to be pointing up. All right, it's going to be pointing up. We've got a multiplier of 4. And so what I'm going to do here is I'm going to use my vertex, and I'm going to use the parent parabola idea that I showed you before. And we're going to go ahead and graph this. Okay, so I'm going to go over, if I normally would go over 1, I typically, right, the ratio or proportion would be over 1, up 1. But a is 4, so it's got a multiplier of 4. So we're going to go over 1, multiply that, right, square that, up 1, and then multiply by 4. So over 1, up 1, 2, 3, 4. That's my next point. I'm going to mirror image that across my axis of symmetry, and I'm going to move on to the next one. Okay, typically if I were to go over 2, I would go up 4, right? Over 2, square 2, that gets you to 4, and then I'm going to multiply that by 4. So I'd get 16. I'm not sure I can fit that in here, so let's see what happens here. 4, 8, 10, let's see, 2, 4, 6, 8, 10, 12, 14. Oh, all the way at the top there, okay? And then I'm going to mirror that again over my axis of symmetry. And then what I can do is I can go ahead and I can draw my parabola. Okay, it's just a sketch. We're just sketching it. Okay, and you can see this is a vertical stretch going up very quickly. All right, there we've got it. Okay, now intercept form. Intercept form is when we have something that's a little bit more factored, right? Same idea. We've got y is equal to a, and then we have the factors here, right? So instead of having something, right, in this previous one, we have it squared, okay? In this case, we have it, x is going to square itself because it's factored form, but what we're going to do is find p and q, right? So p and q, okay, p and q are going to end up being my vertex, because if I plug in p here, right, p minus p will make the whole thing go to 0, okay? Oh, I'm sorry, well, I'm getting ahead of myself, all right? Sorry, p and q are intercepts, right? The x-intercepts. because if x is p, all right, y is going to be equal to 0. So I will know where it hits the x-axis, okay? So I'll show you what it looks like here in a second. Again, your axis of symmetry is then going to be halfway between P and Q, which is what this says here, okay? You add them together, divide by 2. It just means they're halfway between each other. I'll show you what that looks like also. And again, A is less than 0, opening down. A is greater than 0, opening up. Okay, it's really just the multiplier on how we're going to work with the parent function, the parent parabola. All right, so let's go ahead. I want you to tell me what are the two intercepts, right? So it's going to be, I want to know what P is going to be equal to. I want to know what Q is going to be equal to. Oops. Okay. Wow, the pen. Come on, board. Keep up. Okay, so what I'm looking for here, remember, is it's going to be P and Q is where P comma 0, right, and Q comma 0. All right, so you tell me what they are. Go. All right, hopefully you are able to decipher that if x, right, if x is equal to -3, right, that's going to be one of the x-intercepts here. And then when x is equal to 1, okay? Hopefully you can see that, right? Because this, if the x is -3, the whole thing goes to 0. Well, it'll be -3 comma 0. If x is 1, 1 minus 1, 0, the whole thing will end up going to 0. So those are the two spots in which the parabola will cross the x-axis. So I can go ahead and let's put this in here at x is equal to -3, 1 to -3, okay? And then I've got x is equal to 1, so I'm going to go ahead and click put in 1, all right? Then I need to find the axis of symmetry. So my axis of symmetry is just going to be halfway between these, right? So a couple ways you could do this. We could say -3 plus 1 all divided by 2, so -3 plus 1, -2, -2 divided by 2 is going to be -1. Okay, so I just had to pause this and start back over after talking to a colleague. So I apologize if it's a little bit, if I repeat myself or jump ahead a little bit. So I think I was saying you could add -3 plus 1 and divide the whole thing by 2 in order to figure out where your axis of symmetry is at -1. Or you could look at these and say, hey, look, they're 4 apart. So halfway is going to be 1, 2. Right? So my axis of symmetry is going to be somewhere along there. So we know it's going to be at -1. What we can do from here, you plug it back in to figure out what y is, okay? That's one way of doing it. So let's go ahead and do that. So y is equal to 2, right, times -1 plus 3, and then -1 minus 1. Okay, now what I want you to do is look at this also and say, wait a second, okay, the parent parabola, all right, is it goes, you know, as you move away from the vertex, if you move 1 away, you're going to square that to go up, okay? If you move 2 away, you're going to square that to go up 4, okay? In this case, I know that my A value is 2, right? So if we reverse this, if I move 2 spaces back to the vertex or to the axis of symmetry, I should be at, and I square that, it's going to be 4, right? And then what I'm going to have to do is multiply that by 2, so it'd be about 8, right? So I'm guessing I'm going to be at -8. That's my guess from here, okay? Using the parent parabola idea, right? Move 1, 2, that would be squared to get to 4, and then square that to get to 4, and then multiply by 2. So let's just see what happens here. So then we're going to get y is equal to 2 times -1 plus 3 is 2. Okay, and then -1 times -1 is -2, and sure enough, it's going to be y is equal to -8, and so we can go down. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so what I was doing there before, what I said is, from my vertex, I would typically go over 1, up 1, right? But I'm going to square that. So square it and then multiply by 2. So my next one will be here. Okay, and I can mirror that over the axis of symmetry. Next, 1, 2. Right? Normally I'm going to square that. So 2 squared is 4. Up 1, 2, 3, 4. But I need to double that because A in this case is 2. And it's positive, meaning the whole thing is going to be opening up. Okay? And then so I can move up and go on from there. Okay? Okay? If the parent parabola proportion idea that I'm using is confusing you, please bring your question into class. Make sure that we have a chance to go over it, okay? Let's take a look real quick. I want you to go ahead, change these into standard form, okay? So what you're going to do is you're going to go ahead, change these. Standard form is y equals ax, okay, squared plus bx plus c, okay? I want you to do those, bring those into class, and we will rock on from there.